Okay, I'm going to try my best to help you with doing sketches of graphs of polynomials. Now, I'm teaching myself Algebra 2 as I work through this because I am a middle school teacher, but it's been fun because I haven't done this in a while and it's pretty kind of fun. It's like solving puzzles. Okay, so the example I'm using, and if you are having a hard time with sketching graphs, I highly recommend going into lesson 10, the multiplicity lesson, and watch the videos for that lesson. And I also added a really good video to your study guide, your test review folder that I found on YouTube. It's just a guy kind of going over the graphs, and I thought he did a pretty good job. So feel free to watch that video. I'm going to do my best. Now, we have this example here, y equals, okay, x plus 3, x minus 1, these are just the factors, and then x minus 4. Now, some things I know about this before I even see the graph. So I can see the graph. This is in the lesson summary, so I already know what the result is going to be. But what if I didn't? Like, what if this were on the test and they're saying, sketch a graph, okay? So I know there are 3 factors, and I can see that my x values are all positive. So I know that before I do any like multiplying, I know that this is going to be an x to the 3rd value. And it's positive. So I know my graph, and again, just like it's shown there, I know my graph is going to do a number like that. Okay? I've got my 3 is my number of waves, right? I think of it like waves. Like if I'm thinking about waves and I know that I have a power of 3, I know I have to go like up, down, up. Okay, up, down, up. And I'm going up first because this is positive. Now, if this were a negative value, a negative x to the 3rd power, even if there were a coefficient here in front of it, it would be down, up, down. Okay, so that's a given. So when I'm sketching my graph, I'm just going to look at that leading coefficient and pay attention. If the exponent is odd, you know you're going to have an odd number of waves. Up, down, up. So that's 3. Okay? Now, just to show you an example, what if it were 4? If it were 4 and it was positive, then it would be up, down, down. Whew. 1, 2, 3, 4. And if it were a negative, it would be down, up, up. Okay, so those are some things that you can learn. This is called end behavior. And again, if you're still having trouble with that, if you go into, let's see, right here, 8 and 9. Lesson 8 and 9 will really go over these end behaviors. That will really help you with graphing too. All right, now the next thing that we can do is we can locate the zeros. So let me scroll back down to that graph and let me zoom in here. Okay, so I can, when x is 0, I'm going to try to make that 0 pair. I'll come back to when x is 0 in a minute. That's the y-intercept. But let's look at where we can make zeros. So if I input a negative 3 here, that would make 0. If I put a positive 1 here, that would make a 0. And if I put a positive 4 here, that will make a 0. Okay, so now I know that if I sketch this graph, and I'm just going to do just a quick rough sketch, okay, I know I'm going to have a negative 3, a positive 1, and a 4 on the horizontal axis, okay, the x-axis, when x is these numbers. So I'm going to graph them real quick, and I'm off my graph just a little, but that's okay. Negative 3, 1, 2, 3. There's my negative 3, my positive 1, and my positive 4. 1, 2, 3, 4. Okay. So now I know, okay, that I have this type of graph, and I have my intercepts, my x-axis. Now, the minimum and the maximum is really difficult to find because that's calculus, and we're not quite there yet. But we can sketch, and we can at least get the y-intercept. Remember back in like 8th grade, Algebra 1, where the graph crosses the y-axis. Okay, so wherever that graph is crossing the y-axis. And how do we find that? When x is equal to 0. So if x is equal to 0, we have 3 times 1 times 4. but this is negative and this is negative. So if I plug a 0 in for each one of those x's, I can see that it's 3 times -1 times a -4, which is going to be -3 times -4, a positive 12. Okay, so now I know that my graph's going to cross somewhere on that positive 12. Now, I didn't do such a great job of graphing because I have my y equals. So I'm going to get this kind of out of here real quick, just so I can graph. Okay, I live by whiteout, by the way, guys. Okay, I'm going to extend my line, and I'm going to count up 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Now again, this would be like a sketch, right? So you might not even have graph paper. Like this white, there's no graph paper here. So you could guess, you could kind of estimate. So this is my 12. That's how I got the 12, by just making x equal to 0 and then multiplying straight across. 3 times -1 times -4. So now I know it's going to go up, down, up. I know that my coefficient is positive. That's why I'm starting with up, then down, then up. I know it's going to cross here. I know it's going to cross here, here, and here. Okay? Now, the multiplicity. The multiplicity just says that when nothing's repeating. See how we don't have a repeat? This is not x plus 3 to the second power. We have one of each. So we have an x plus 3, an x minus 1, and an x minus 4. So there's no repeating. So we would say that this is a multiplicity of 1. That means the bars, the waves, are going to be the same kind of distance away from each other. So it's very even. So I'm going to do my best to sketch. I'm not very good at this, guys. Okay, my graph is going to go, it's going to go up, down, just something like that, okay? Now, my lines are closer together because of the scale and the space between my line segments. So my graph paper is really tiny. If I had skipped and done like every other graph, a 1, then 2, then 3, it would be further apart. But notice my lines between the two are fairly even, the same distance, okay? This one's a little squishier. I could probably tighten that up a little bit, but it's close enough, okay? Remember, this is a sketch. It does not have to be perfect. Okay, let's scroll down and look at this one. Now, this one is a little interesting because right away I'm looking and seeing x plus 3 to the second power. That means this is going to have a multiplicity of 2, okay? Because there's 2 of them. There's 2 of the exact same factor. So if I'm looking at this graph, y equals x plus 3 to the second power. What that is x plus 3 times x plus 3. I encourage you to write this out, like so you can see it. And then x minus 4 times x minus 4. Okay? And again, I would encourage you to expand when you have 2 of something so you can see it. So here we are again with our 3 x times x times x. There's 3 factors. So again, I know this is going to be an x to the third power. These are all positive. All positive. So again, it's just going to be like this. Zoop, 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 right? Up, down, up. Okay? Positive. So I'm starting in the up direction. Then I'm going to go down. And then I'm going to go up. 3 arrows. Up, down, up. 3, positive. Okay. Now, how can I find my zeros? So I have to be a little careful with this because this is 3 to the second power, okay? So if I plug this in 0 or -3, -3, positive 3, that would be 1. So I'm going to write that down. This is a -3. That would give me my 0. And then my positive 4. Okay, so now I have my direction of my graph. I know it's going to be 3 waves, up, down, up. I know it's going to cross the x-axis at -3 and positive 4. Now the only other thing that I could get that would help me is where will it cross the y-axis? Where will it cross the y-axis? So if x is 0, that's where it will cross the y-axis. So all I have to do is replace these with zeros. And when I do that, it just ends up becoming 3 times a -4. 3 times 3 is 9. And 9 times negative 4 is a negative 36, folks. So this dip, this part right here is going to go really far down. Okay, so let's see if we can graph it. All right, so we already know what it looks like. So we're just kind of working it backwards so we can see. We know the end result. I'll be honest with you, I like knowing the answers and I like working things backwards. I like seeing the answer and then going, how did they get that? That's how I learn. So I don't even mind you having the answers, but make sense of how they got the answer, right? How did they graph this? Okay, so here we go. What do we know? Up, down, up. All right, and I have my zeros. So I am going to look at my scale. So it looks like they're counting by tens. I'm not going to do that. Well, I guess I could, because otherwise negative 36, I'm not going to have enough room on my paper. Maybe fives. I might just do negative 5, 10, 15, 20, 25, 30, 35, 40, 45, 50. Okay, so 5, 10, 15, 20, 25, 30, 35. It's 36, so it's going to be pretty close to that. So I know my graph is going to cross here on the y-intercept, on the y-axis. I know it's going to cross negative 1. I'm going to actually skip. Well, no, they're odd. Yeah, we'll skip. We'll do half 1, half 2, half 3. Okay, so this would be negative 1, negative 2, negative 3. I'm just making my graph a little bit wider. All right, and then 4. Half 1, half 2, half 3, half 4. You can be in control of your scale. That's what's cool about a sketch. All right, I know my graph is going to cross down here at negative 36. I know it's going to cross here at negative 3. I know it's going to cross here at positive 4. Now, because this is going to be a wave that is kind of a little off balance because I have 2 x plus 3's. See that? So I know that my first wave is going to be tighter and closer together than my second wave, because my second wave, there's only one of them. Now that's the multiplicity. Okay, it gets a little confusing, but again, on the test, it's not going to be that much of this on the test. I know it's going to be up, down, up, but it's going to be like this, maybe like closer and then further away. See how I kind of did that? This one's the closer because there's 2 of them, so that would mean a multiplicity of 2, and there's only 1, so that's a little more evenly distributed. All right, let's see if I can do it. Up, down, up, up, down, up. Okay? Something like that. Again, I'm not grading you on your artwork. When I look at your graph, it's fairly close. I give you credit. Okay? I hope this helps with graphs. And again, like I said, if you go into our Schoology folder and you check the video that I added to your review, that one's good. Lesson 10, any of the videos for Lesson 10 will really help as well.